So this is a medical image analysis model. It is a model which will detect three diseases: lung cancer, Alzheimer's disease, and pneumonia. Let us test this model one by one. First of all, for lung cancer. Okay, this is the data set for lung cancer. Training set and testing set are different. Let us test for training set, because I have made this model using training set, this three training set, and I have divided this images using pre-processing technique. Now let us check for testing set. For example, this one, squamous carcinoma. Let's see, it will be detected or not. It will be able to be detected or not. Squamous carcinoma, okay, with 99% accuracy. Let's check once more. Let's check adenocarcinoma. We can take any data. Let's say this one. So it is a adenocarcinoma with 100% accuracy. It is able to predict it. Let us check finally for benign. Let us check any data from middle one, this one. Just taking time. Benign, 100% accuracy again. Okay. Now let's check for Alzheimer's disease. I have this data set here. Let us check it for first non-demented testing set. Let us check any one image. Suppose let's check this one. It is non-demented. Successfully verified. Okay. Now let's check again. Any other, maybe from down. Let's check this one. Same non-demented, but with one of the best accuracy. Now let's check for a person who is having this disease. Uh, okay, here, moderate demented for testing purpose. That can check any of the data. For example, this data. So it is moderately demented. Uh, Confidence score is 62%. That means it is not highly infected, but the symptoms are there. Let's check once more time. Moderately demented. I can take any data like this. Since again moderate but with higher accuracy or higher confidence score. That means almost this X-ray image is almost infected. Now let's check for pneumonia. For that we need test X-ray chest, X-ray image of chest, then pie chart, chest X-ray for training set. Let us check for pneumonia first. Suppose let's check this one. Okay, pneumonia with 99% accuracy. Let's check once more time. Any data in the lower part, maybe this one or this one. Pneumonia with 99% accuracy. Now let's check for a person who is not having pneumonia or having slight, very much slight symptoms of pneumonia. It will be decided by confidence score. Okay, we can just check any of the images. Suppose let's check for this image. Okay. So it is showing pneumonia. That means it is in the verge of getting infected by pneumonia, or it is showing the good symptoms of pneumonia. Let us check for another image. Maybe this one. Okay, it is showing pneumonia symptoms, but the symptoms are approximately negligible. That means it is near to normal. Let's check once more time. Check this one. This time also very much less chances of getting infected by pneumonia. Confidence score is very less, about 5%. Let's check one more time. You can take any data. Let's check this one. Normal. See, it is saying that 99% this machine is telling that he is normal. That means he is not showing any signs, any symptoms of pneumonia. It is far away from getting infected by pneumonia. So if we talk about the model which was coded for creating this project, it is made up of two Python classes, main and util. So I have used Streamlit for creating API and convolutional neural network for detecting the or for training and predict and making the machine to predict the model using CNN. It is implemented here. So if we talk about from beginning, here I have set the background by importing this set background class from util package. Util class set package, and it is passing image file which I have in my local memory. Similarly, this markdown is used to, you know, used to display the. Okay, I'm splitting the screen here like this. Okay, so it is used to display the disease detection model. Here, the same way disease detection model, and then the st.radio. That means I'm using Streamlit to print the bullet points here. Uh, Next, I'm using again st dot markdown to print. Please upload the medical image of the patient, and then I'm writing a code which is creating a, a box by which we can import a file or the medical image of the patient. Okay, and then this code is written in case if we want to detect more than one diseases. For example, this project is for Alzheimer's disease, lung cancer disease, and pneumonia disease. I have a pre-processed model path for separate model path for these three diseases, which I have trained using external website. And this model path it contains a H5 folder, which is nothing but a trained classification model, which will be used to predict the disease later on. And this levels path indicates the level of a particular disease. For example, in Alzheimer's disease, we have levels as demented, non-demented, and moderate demented. Similarly, for lung cancer, we have three level paths, and this level paths are stored in the form of array. We will see in the coming codes. This level path is in the form of array, and it contains uh, array of all the levels of a particular disease. For example, lung cancer, maybe zero. In zero you will get the adenocarcinoma. In one you might get the other type of other type of carcinoma which you want to detect using lung cancer. Similarly, for pneumonia you will get two types of level path, 0 and 1, 0 for pneumonia and 1 for normal. Similarly, I'm using this model path to create a model, and this model will be further used to make prediction in util class. Okay. Now here what I'm doing, I'm creating a class names array, and it is doing nothing but extracting the class names, actually the levels of different types of disease which you want to predict, and then it is storing in the form of array. First of all, this code is extracting because level path is actually in the form of text. If you see here, all are from the text. Here also text, here also text, here also text. So this code is actually extracting it in from the form of text and then storing in the class names, and class names is in the form of array. Later on we will be sending it to the util class. Okay. Now print class names. Here I'm putting the class names, whatever normal. See, this is the class name. Now if file is not none, suppose you have imported a file here, and then we are doing some processing with the image. Why? Because you see, this file may seem to occupy whole of the website, but I want it to occupy only a part of website. So I have resized it to 2224 Okay, this is not pixel here. It is not pixel. And this RGB format, and this is RGB format means it is a part of syntax. That means our code expects our image to be in the form of RGB, otherwise it will not run. And then I am using Streamlit to print the image. Uh, in the to print the resized image, I am resizing here and then printing here, and I have written yes, use column width equal to true. It means that actually column width equal to true. Actually, it is a self-adjusting code. For example, this code will adjust the width of this image itself. For example, this length. See this length and see the length of this image. It is adjusting itself uh, its own way. Okay. Now I'm declaring here class name and confidence score. It is in the form of tuple, which will be returned by classify class, and this classify class is declared in util class. Okay, and then finally we are printing my class name or confidence score here. This is class name and confidence score after predicting, and you know that this prediction is always done in util package, which we will see. Okay, and then remember that what is this model path actually? This model path is a trained model. Okay, trained classifier model. Okay, what is it is doing? It is for example, it is in the form of H5. Okay, H5, we call it HDF5. Okay, HDF5 is a format in which a large amount of data is stored in the form of multi-dimensional array. It is basically for saving memory, and then the data which is stored in HDF5 is not only in the form of format, no, sorry, not only in the form of architecture, but also in the form of some datas which are stored in there, which may be in the form of intensity or something else. So, what is the implementation of this model path for Alzheimer's disease? It is written here, and then this whole text is expected or is squeezed in the form of a file known as this keras model.h5 or hdf5 file. Okay, now let's see util package, util class, sorry. So I've imported this base64. This base64 is actually encoding decoding library in Python, which is used to maybe print the background image. Why? Because we do not want the 10 MB image to send here and there. Okay. First of all, we will convert the image in the form of maybe some text. Okay, and we convert it by using base64, and then that is what we are doing here with image data which we receive from image file. Okay, and then this whole code is actually doing nothing but printing the background of my image, which is this one, whatever you are seeing here. Okay, and then here def classify. The classify this is the most important part of the whole program where convolutional neural network is being implemented. And what is it? It is expecting that it is expecting four parameters, and all those parameters are is passed by main method. See here, class name, yes, this one, and then this classify method will return two things in the form of tuple. We'll see here. So first of all, we are extracting image, whatever user has sent us, suppose this one, and then first of all we are we are resampling it. Resampling is very much necessary in convolutional neural network because because at times we want to compare different data, different images, and if all the images are in a completely different format, then it becomes very much difficult for machine to compare them. So it is very much important that all the images which you extract all should be in a particular format. And format, it may be in the sense of anything, but for resampling case, that format is basically the size compatibility which is being implemented here. This 224, 224 is not actually the size, it is actually the number of pixels length and breadth wise. If there might be if there can be cases where we have three-dimensional pixels which we call voxels, we can see such type of problems in case of 3D lung tumor augmentation problem. But here we have simple three diseases which requires only 2D two-dimensional pixel coordinates. Okay, so image is made up of pixel. Just imagine image made up of small Rubik's cube, and there are 22 to 4 Rubik's cube in length and 2 to 4 Rubik's cube in the breadth size. Okay, and then what we are doing that we are creating an array of that image array. That means this image array consists of all the pixel values in the form of array, and that pixel values is storing data, and that data is representing the intensity of that image. For example, this image consists of many pixels. If you count all those pixels, it will come 2 to 4 here and 2 to 4 here, and every pixel, suppose the pixel which is present here is dark, but the pixel which is present here is having a data which is having a higher intensity. Similarly, all those data is stored in this image array. Now further we will normalize those datas. Why? Same reason. We are doing it for the sake of compatibility in comparison and learning model. So we are dividing it by 127.5 because we want the whole data to be in the range of maybe 0 to 2, and then if we divide it by -1, then the whole data will come in the range of -1 to 1, and then it will become very much easy for machine to train and as well as predict the class name. Actually, the model is already trained, which I have sent it here. This code is written here only to predict data. Now what I'm doing is I'm creating an data array. It is, you see, four-dimensional array, 1, 2, 3, and then 4. 1 means the number of images which you are passing here. This 2 to 4 means the same pixel size, and then 3 is the maybe RGB format. RGB means 3 type of color coding which you are sending here. Okay, huh? So it is also seen here. What is number? Okay, this is something different. Okay, data type float. Okay, this is only possible if you store the elements of data in the form of float. It will not support the integer data type. If you will not write, then it will be a syntax error because it is predefined array, and it requires it requires two parameters to be passed. And then what we are doing is we are passing the normalized array in the first index of this data array. Further, this code is actually this line of code is actually predicting the class names of the image which it is trained for. And then I have written this code because I have different diseases. I have lung cancer disease, Alzheimer disease, and pneumonia disease, and algorithm may be different in all those cases. So if prediction 00 is greater than 0.95, that means if you are highly confident, then only send index 0, otherwise send index 1. 0 in index is again here representing the array, okay, which is stored in this one where class names. Okay, 0 means some maybe class names may be defected, or 1 means not defected, depending on what it is there in the internal memory. Now similarly here what I'm doing is index equal to np.argmax. Suppose if you are not checking it for pneumonia, suppose you are checking it for Alzheimer's disease or lung cancer, then you have to apply this algorithm. Why? Okay, so we are doing it because this new because I have very much less data for pneumonia. Okay, and pneumonia requires the X-ray image of chest, which is it, and it is very much difficult for machine to detect the X-ray if you have very much less amount of data. And then it is a kind of optimization which I have applied here so that the performance of my model get increased. But if you are having Alzheimer's disease or lung cancer, then it is actually in the form of a colorful. If you see the lung cancer image, it was in the form of colorful images. So it becomes very much easy for machine to learn, and not much amount of data is required for machine to learn here. And in that case, this line of code is enough to get the highest accuracy protection, and we don't have need to apply much more logic which is being implemented here. So index equal to np.arraymax means if you are highly confident, suppose if the prediction is 0.9 or something, if you are highly confident about the prediction, then only return the index. If you are less confident, then return the return that value. Okay, and then here argmax is here used, which is the library, which is the method, which is the functionality provided by NumPy package. What it is doing is actually is sending the maximum value of whatever you are thinking. Suppose if you are maximum probabilities of whatever the machine is predicting. For suppose machine is predicting 0.9, then it will send 1. If it is predicting 0.2, 0.3 or 0.4, then it will send 0. The same class name is equal to class name index. Suppose 1 is corresponding to normal, then class name will store normal. Suppose 0 is predicting pneumonia, then class name will pneumonia, depending on which type of disease you are treating. Okay, and then confidence score is being computed by finding the exact location of prediction, which is defined here, and then finally we are returning this to tuple, and then this tuple is getting called here in the class name and confidence score, and then finally we are predicting class name and then confidence score. And then there are much more things which is being done here, but this was basically a crux of it. Thank you.